Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 20th. Taking a look at significant wave heights for the North Pacific Ocean, we see an active pattern still in play. An area seas off the California coast from a gale, previously just in the Gulf of Alaska, is impacting the coast, creating large, somewhat unruly surf along much of North and Central California and starting to work its way into Southern California. A new gale is starting to develop over the northern dateline region, bound for the Gulf of Alaska, and yet another gale is starting to queue up over the North Kuril Islands, bound to track east and also generate swell. So, our active pattern that has been in play for weeks now appears to still be in play. As usual, we'll start this week's tour off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales do form, help direct their path. We're looking for a trough, a dip in the jet, just like there, just like there, just like what has been going on for weeks now, with all the troughiness really isolated to the Gulf of Alaska and sort of a semi-permanent ridge that is the jet sort of pushing to the north over the northern dateline region. Unfortunately, this really cuts Hawaii out of most of the swell track, and all the swell generation is occurring in the Gulf of Alaska, focusing on the Pacific Northwest down into California, and we don't see an immediate change forecast. But also notice, as of now, Sunday 18Z, we have a bit of a split in the jet occurring. That also suggests high pressure between the north and the southern branch of the jet here, and that also contributes to this ridging pattern that has been in play over the dateline and this troughy pattern that occurs over the Gulf of Alaska. We believe this this ridge is, or this split here and the ridge is to be a little bit short-lived. Let's get into the details. So, trough number one here, not being fed by a whole lot, but this is the start of a new gale developing this area. This, a pinched, very steep trough, still has good wind energy falling into it in the, about 130 knot range, but it is all but over, pushing onshore. The front has already preceded it, moving onshore in Central California today. The good news is there is snow in the mountains now. It finally got cool enough. Accumulations lower Sugar Bowl area were in the 1 foot range, and about the same for mid-levels at Squaw Valley. Putting this into motion, let's see what happens. Here comes our next trough developing, being fed right here by about 120, 130 knot winds. Not looking particularly as strong as some of the troughs ahead of it, and this split in the jet here already starts fading out come Monday night. Anyway, the Gulf trough starts to fade, but look, more energy here. Was at 1, 2, 3, that's 160 knot winds feeding into it, and there we go, yet another trough developing as the first one starts pushing inland on Wednesday. And notice this, a good batch of wind starting to develop off Japan on Wednesday. Next trough pushes into the Pacific Northwest in the Thursday Thanksgiving time frame, and then we just have, look at this pattern. This is pretty much textbook to what it's been lately. Coming off Japan, ridging over the dateline, falling into a gentle trough in the Gulf of Alaska, pushing onshore over the Oregon, Northern California border. If this continues, and there is every expectation that it will, one would think more precipitation would accumulate over the Golden State, very much a needed commodity. Anyway, roll through this, and here we go into Friday, another trough, this one right off the U.S. West Coast, focused on Washington. A little bit of wind energy pulling into it, but nothing too powerful or anything. And then we get into Sunday, a week out, and notice a pocket of 190 knot winds developing here off Japan, a trough starting to set in west of the dateline. Maybe this will offer some opportunity for Hawaii, and a ridge starts pushing into the Gulf of Alaska. That would cut off low pressure development in this area, and if anything, set up a calmer pattern. And the focus would then turn to the West Pacific. But here we go, 180 hours out, and there's already a suggestion that that trough's going to start lifting north. But still, something to monitor. This here suggests perhaps a backdoor front pushing down the U.S. West Coast. Cooler air, perhaps, but that's speculation at 180 hours out. Let's go take a look down at the surface. So here we go, surface level pressure, surface level winds. As surmised, the next gale queuing up in the Gulf of Alaska, 40-knot winds, taking aim on the U.S. West Coast, sideband energy into Hawaii. Typical pattern that has been in play for quite a while. High pressure, 1032 millibar high, setting up over the dateline. That is what creates that ridge. The jet stream rides over the top of the high and then down, and the falling motion helps create counterclockwise circulation. You can see it right here down at the surface. And of course, the difference in pressure between the high and the low creates a pressure gradient, tighter isobars, which results in wind, which is fetch, which creates seas, which when they radiate away from that fetch area, creates swell, which of course when it hits your beach, creates surf. So much for the education. Onward, looking at the models. Get into Monday morning. Nice gale here forecast in the Gulf of Alaska. Not particularly strong, but a broad area, 30-knot winds with 35-knot peaks in the Corvette. A secondary gale or a second gale setting up over Kamchatka with 45-knot winds, but a lot of this wind back here is all blocked by the Kuril Islands and of no use to us in terms of swell production till we get into Monday night, and then you have 50-knot winds pushing off the Kuril Islands and 35-knot winds here. I mean, really, you look at this is almost a continuous fetch from just off Oregon to Kamchatka. That's quite a bit of fetch there. Anyway, moving along into Tuesday, you can just see how the systems evolve. Then they start weakening and fading out come Wednesday. New system tries to develop here off Kamchatka. Another system trying a secondary system, re-evolution of this existing fetch developing Wednesday in the Gulf of Alaska. 30-35 knot winds. That's good for a 12-13 second period swell. And we'll just sort of roll this out as another little patch, 45 knot winds into Thursday morning. Fetch continues here, but most of it landlocked over Kamchatka. High pressure feeding trades. This is typically what happens during La Nina. You get this big high pressure. Normally it sets up right here. If the bulk of the cold water associated with La Nina on the equator, oh, there's the equator right there, is right here. But most of our cold water in this La Nina is out here. It's like sort of like a Modoki La Nina, and therefore the high tends to be a bit weaker and pushed off a little bit more this way, which is a good thing in terms of getting precipitation into the Pacific Northwest and down in California. Anyway, moving on, Thursday, the system sort of moderates a little bit. Local low come Friday, pushing into the Pacific Northwest. Swell generation, likely. We'll take a look at the seas forecast in a minute. Certainly a lot of wind and weather as well. Rolling on out, and then things kind of mellow out a little bit. Another local gale on Sunday, and then something starts developing here towards the dateline come Sunday night or so. Hard to tell what's going to happen, but there's a big blocking high pressure. My guess is this low is going to push up this way and probably not have a whole lot of impact on anybody. Another low again developing, pushing off Japan. So the short side of it is, looks like a very active pattern. Maybe not ideal for swell generation, but pretty good for precipitation. And there is not enough good that can be said for that relative to the U.S. West Coast. And then finally, we take a look at the impact of those winds on the ocean surface. It is, of course, the wind that creates seas. And here we go. We have seas, what is that, 25-foot seas? Notice the X denotes the maximum winds, location of maximum winds across this entire GRIB area. The plus sign right there, you can see it here, is the maximum seas across this entire area. So we have 41 knot winds and seas at 25.7 feet right here, basically 25-foot seas. That's good for a 14-15 second period swell. So already more swell is being generated, and there is significant seas and swell already pushing into California. Large, 15, 18-foot surf today at some locations. A little bit wonky, but still, large seas help break up some of the sandbars. Maybe a good thing. Anyway, so we roll into Monday. The gale pushes into the Gulf of Alaska. Seas in the, what is that, about 26-foot range. We'll roll on out here. New gale develops off Kamchatka, 37-foot seas by Monday night, and 25-foot seas continue in the Gulf of Alaska. And then, what is that, 41-foot seas? Now, this is better. This gale initially was just supposed to go boom right into the Bering Sea. It looks to be taking a little bit more southern track now, and that helps push more energy towards Hawaii. And the Great Circle paths right in here, they sort of go like up like this and down like this into California. So this is, in fact, exposed to California to a certain degree. Anyway, so more gale energy Wednesday. I mean, it just goes on and on and on. Consistent 20-foot plus seas. So that's 13-second swell or better for the foreseeable future. And we get into Friday, see kind of local 22-foot seas. I mean, it just goes on. Another system off Kamchatka, not nearly as good. And here's the first break we get come, let's say, Saturday. The ocean, the jet, the atmosphere kind of calms down. You get the sense high pressure building right here in the area of the lowest seas. And that ridge building over the Gulf of Alaska. Maybe a change in pattern setting up, but probably not. And then we get out into Monday, and you just get the sense that another gale's going to get going in both places. Seas will build. But for now, it looks like, there should be plenty of swell the whole way through the Thanksgiving holidays relative to the U.S. West Coast. The issue is wind and rain, and someplace that's actually protected enough to make the best use of whatever swell is generated. Southern California should probably do fine, but the further you get up towards San Francisco, the general outlook looks pretty raw and windy. Let's move on, taking a look at long-term projections. And the two things we like to look at long-term are the Madden-Julian Oscillation, that 3 to 4 week oscillation that runs across the Pacific Ocean, equatorial Pacific, from west to east, and of course, La Nina, or El Nino, commonly known as ENSO, the El Nino Southern Oscillation, and this has more a 4-year on and off type of effect. Right now we are in La Nina. One would not guess based on what's happening in the North Pacific. But last year we suggested that really what we're seeing right now is not the effects of La Nina directly. It is the hangover from El Nino in the upper atmosphere. It's still circulating. It has not completely faded away. That is enhancing the jets still. And that's expected to continue into maybe the mid-December time frame, and then maybe a bit of a break. But who knows? Sometimes these things take on a life of their own. Anyway, let's get into the details. So first up, we like to look and monitor the MJO, specifically in the Kelvin wave generation area. Here's the date line. This is the equator. This is the Pacific Ocean, New Guinea right here. We're looking at winds. This is actually buoys. There's arrays of buoys strung across the equatorial Pacific to monitor El Nino, La Nina, but they're also good for monitoring the MJO. Currently, we see trades pretty strong across the entire equatorial Pacific, but a little bit weaker over here in the Kelvin wave generation area, which is from 170 west right here to about 135 east and 5 degrees north and south of the equator. So you can draw a box right in this area. We see trades in effect. Here is differences in normal. We're just looking at the arrows right now for this time of year. Anomalies, that is. We see weak easterly anomalies. That's pretty normal with La Nina. If you had a strong active phase of the MJO, it would actually completely kill the trades or reverse them, and you get anomalies from the west. That can, if you have a broad area of westerly anomalies, it can take warm surface water that's here, start pushing it east to depth, and that is what is known as a Kelvin wave, sort of a bubble of warm water that traverses under the equator about 150 meters, and then eventually will impact the Galapagos and the Ecuador area, erupting to the surface, causing a warm pool, and that often is what helps jumpstart El Nino. Clearly, that is not happening now. Trades are in effect, anomalies from the east, and have been for a while, all driven by La Nina after coming out of a 2-year El Nino. We can look at the forecast for the next week. This chart here, zonal wind anomalies, is actually the east-west component of wind up at 850 millibars, which is about 4,400 feet in the air, which is a pretty good proxy for what's going on at the surface. It sort of overstates somewhat of what's going on. Kelvin wave generation area, date line is here, and 120 east is right here. So Kelvin wave generation area is roughly right in here. Blues are easterly anomalies. This was back in early November. It moderated a little bit. Here's the forecast for right now. You see we have still weak easterly anomalies right on the date line. They're forecast to build. This is pretty much what's been going on. The MJO, even when it turns active, has all it does is like right here. This was suspected to be an active phase of the MJO. It didn't kill easterly anomalies. It just sort of dampened them. You didn't get real westerly anomalies. It just goes neutral, and then La Nina comes back in once the active phase fades, and then easterly anomalies pick up. And that is the forecast for the next week. Another way to look at the state of the Madden-Julian oscillation is through outgoing long-wave radiation forecasts. This is assume you're a satellite beaming radar down on the ocean surface. If you have clear skies, you get a better return. That is reflectivity off the ocean from the radar signal. And you would get, if you have a better reflectivity, here you go, you get reds. See the scale? Better response. If you have a lot of clouds, less of the signal bounces off the ocean and returns. You get negative anomalies like here. So this could be assumed to be more clouds and the active phase of the MJO. This would be the inactive phase of the MJO. So the assumption is the inactive phase of the MJO is in the far west Pacific and over the next 2 weeks scheduled to make its way to the east while fading. This per the statistical model, the CA model. The GEFS model right here, ensemble GFS model, suggests basically the same thing, but the inactive phase of the MJO is not to make as much easterly headway. So one would assume that if the inactive phase is working its way into the West Pacific over the Kelvin wave generation area, that would increase trades. That in turn would help to split the jet stream or weaken the jet stream, which in turn would result in less storminess, less gale activity, which in turn would mean less surf. So we'll see whether that plays out or not, but that's the forecast per this model. Another way to look at where the active phase of the MJO is per this phase diagram. So assume you're looking down on the north pole of our planet. The MJO travels from west to east or counterclockwise around this diagram. It goes from the maritime continent, consider that Bali, over the date line into the West Pacific, across the Pacific, across, and really we're talking on the equator now. So under America, under or across the Atlantic into Africa, and then back to the Indian Ocean. And the MJO makes this continually traveling around the planet on the equator. The active phase currently right now is in the Indian Ocean. The further away the big dot is from, if it were way out here, it'd be very strong. This is medium weak, if anything, and the forecast over the next 2 weeks is for it to utterly collapse in the Indian Ocean per both the ECMF model and the GEFS model. So that's probably true. This all suggests that the inactive phase of the MJO is probably going to take over in the West Pacific. And one other model we like to use, the CFS model, again, up at 850 millibars. This chart has previous history on the top, on the bottom, going to the forecast at the top. We'll overlay so you can see, the date line right here. So the Kelvin wave generation area is roughly along in this area here. And you can look at the forecast. It suggests westerly anomalies somewhere in the Kelvin wave generation area, pretty much. And if you look back down here, you can see none of that forecast. And now it suggests westerly anomalies building come somewhere late November, early December, and holding the whole month of December into January. And then it looks like easterly anomalies start taking over. But in the far eastern Kelvin wave generation area, that probably is not so much of an issue. Let's overlay and see what really is happening. So right now, easterly anomalies here, right here, that blue. Weak inactive phase of the MJO forecast traveling from west to east. Okay, and that's consistent with what the other models are suggesting. Then it suggests we go into a neutral phase, but with these westerly anomalies developing, and even another weak inactive phase, westerly anomalies persisting, and then a more legitimate inactive phase out in the January timeframe. None of this is believable out this far. I'd say maybe into about mid-December or so. is the only thing that we'd really look forward to. And it'll be interesting to see if these westerly anomalies develop, because the model has been hinting at this on and off for months now. We're just about at that point in time, somewhere in December, so we'll see what happens. So the short of it is, this immediate inactive phase of the MJO might dampen things for 2 weeks or so, but then after that, it sort of looks like we're off to the races in December into early January. I don't feel confident in betting any money on that, but that's consistent with what we've been seeing on and off for weeks now. So for right now, inactive phase of the MJO looks like it's forecast to set up. Let's take a look at the ocean, see what's going on. And now we're talking more La Nina, El Nino. Right now, subsurface temperatures, East Pacific here, West Pacific here. These are the TAO buoys. Right, these are the anchor lines on the buoys. The X's demark the sensors strung along those anchor lines, and those sensors help determine temperatures, and you can sort of get a profile of what's going on. Warm water here in the West Pacific, much cooler or much shallower pool of warm water. This is pretty consistent with La Nina. El Nino would have more of this warm water working its way this way, and the gradient here would be much flatter, meaning a much deeper area of warm water in the east. But when you have trades blowing over the surface, that creates upwelling, draws this cold water at depth up to the surface, and kind of, yes, you have the sun heating waters very near the surface, but when you have this constant easterly flow blowing along here, it just kind of takes whatever is warmed here at the surface and pushes it this way, and you end up with this big ball of warm water in the far West Pacific. Eventually, it will get so large, and then basically what happens, the trades collapse over the entire Pacific. The trades reverse themselves over the Kelvin wave generation area, which is right around in here, and then all this warm water starts moving to the east. So that's about every 7 years that'll happen, 5 to 7 years. So it's sort of this balancing act. It's the atmosphere trying to maintain equilibrium, but it always overcompensates in one direction or the other. In the El Nino compensation, it suppresses the trades too much. In the La Nina compensation, it overemphasizes the trades. Anyway, at depth, here we go. The differences from normal, anomalies. And here's the interesting part here. Notice in the past, see these negative anomalies here, cool and water normal. It was almost a continuous run the whole way across the Pacific. And all of a sudden now, and we think some of this is because trades have reduced a little bit because of the active phase of the MJO. Some of this warm water that was over here is starting to creep its way off to the east. We'd love to say Kelvin wave, but there's no way that's happening. It's just creeping to the east. And with the active phase of the MJO likely going to fade in the next week or so, that will probably start getting pushed back. But still, this is approaching a more normal, a more neutral setup. I mean, really, here's the only place where you have -1 degree anomalies, and that's not a whole lot. And then a little bit over here, basically, it's a reasonably even distribution of temperatures, considering that we're in La Nina. Now, this, a different model of this using the same sort of data, also suggests a little bit of creepage or seepage here east of, at depth, we're down 200 meters, so 600 feet or so. A little bit of creepage of warmer water to the east, but still a reasonable, was this 1, 2, we'll say 3, 1, 2, 2 to 3 degrees below normal. So that's a lot different than what this guy's saying here, where it's only 1 degree below normal. This might be overstating it, and the previous chart might be understating it a little bit, but still not horribly bad for La Nina. Upper ocean heat anomaly chart. So this is much like the previous chart, but you're just looking at the top 300 meters of the ocean. And you're looking at heat distribution. West Pacific here, East Pacific here. This is Kelvin waves from the previous El Nino back in December last year and February of this year. And then the onslaught of La Nina, relatively weak La Nina. Cool water pushing its way off to the east, and pretty much a steady state as of right now, and you can start to see the buildup of warm water again here. It's so a little bit of a maturing La Nina pattern starting to take shape. Sea level anomalies. This is actually the using the Jason-2 satellite, strip out all the surf, strip out all the wind-driven waves, strip out the tide, and just how high or low is the ocean surface compared to normal or neutral. What you see is this tongue right here on the equator. Here's the dateline right here. Here's South America, New Guinea here. You see, yes, weak negative anomalies, -5 centimeters. That's not hardly anything. A couple little pockets of 10-centimeter anomalies. This is actually much better than what we saw months ago with the onset of La Nina. This is just more data that suggests that there is cooler water at depth. Cooler water contracts. It sort of gives you a little bit of divot in the ocean surface in this area. If it was warm water at depth, then you'd see positive anomalies here like we did during El Nino back last year and the year before that. But now we have negative anomalies, but nothing super impressive. So this also suggests that the subsurface water, cool water profile is not particularly strong and not particularly impressive. So then we take a look at actual surface temperature anomalies, differences normal from this time of year. And here is what is starting to develop again, this little tongue of cooler water developing along Peru. That actually shut down all this week. Again, what we considered attributable to the active phase of the MJO. The active phase of the MJO was over in the far west Pacific, starts working its way east. I think when we looked in the models, it's actually out over here. And the inactive phase, or at least trades driven by La Nina with the active phase out of here, trades are waking up again, starting to get some upwelling here, also along the Galapagos. So here's our cool pool. Pretty thin and weak right here. It was actually even weaker a week ago. And then the majority of the cool water is out here, more towards the dateline and south of Hawaii. There's Hawaii right there. The trend for the past 7 days, just cooling or heating, sort of suggesting the same pattern. All of a sudden, we're starting to see a little bit of cooling along Peru here where it was all warm, and cooling developing along the Galapagos where it was all warm, and a couple little disparate pockets of cooling, but also a pretty good balance of warming as well. All this suggests is, general, I don't know, I guess we'll say the trend is biased towards cooling, but only in very limited areas. It's just La Nina. If it was really raging, this should all be dark blue here, and it's not, and that's a good thing. And then finally, the overview, the temperature anomalies from normal, and you can see the balance and the biggest area of cooling waters, these blues here, is from, we'll say 130 west out to about the dateline, a little bit beyond that. So this is where the bulk of the cooling is, and so north of there is where you'd expect to see the high pressure and the ridge in the jet stream we talked about earlier, and that's exactly what we're seeing. And then here you can see the storm track pushing towards the U.S. West Coast, winds behind the cold fronts associated with those, creating a lot of upwelling, a lot of mixing of the ocean surface, because there's been a very active storm pattern. But notice most of it, you can see it's dropping south, sort of bypassing Hawaii. And then on the front edge, there all these storms, storm after storm after storm comes through here with a cold front, south winds in front of the cold front, pushing warm water from the north up along the coast. This looks very much like a PDO, an active PDO signal, if you will, which is favorable. So this is the PDO. We've talked about this in the past 20, 30-year cycle. It goes in the negative phase, which basically simulates a long-running 20 to 30-year like La Nina pattern, which is exactly what we've been in since 1998. The thought is, we have turned the corner and things are starting to wake up, and maybe we're moving to the active phase. That would mean 20 to 30 years of stronger storms, more water into California, more surf, etc., etc. But you don't know it till you're a couple of years into it. La Nina sort of has El Nino has biased the picture for the past 2 years. It's only when you get into a La Nina, see how strong or weak it is and see what goes on. And this La Nina, by all measures, is a weak, very weak La Nina. If we get through next year and we return to normal, or we don't have La Nina or a weak La Nina, then that would kind of suggest that maybe we are in fact moving into the active phase of the PDO. Another signal would be also is if the storm track doesn't die out, as we were talking about the storm track, maybe it's all hangover from El Nino in the upper atmosphere, and that's supposed to go on till mid-December. But what if we get into January, February, and the storm track's still doing really good? That would also be another indicator that the PDO is perhaps turning active. So what's the effect of La Nina on the atmosphere? The way you can measure El Nino or La Nina is through the Southern Oscillation Index, difference in pressure between Tahiti. Here's actual pressure, Tahiti, and Darwin. Now, it's some accumulation of a formula. It's not a direct difference, because you can see there's, probably 3, just eyeballing it, 3 or more millibars of pressure difference here, and the index is minus 1.61. But anyway, you get the idea. When the numbers are negative, like there and there especially, that suggests the active phase of the MJO if it goes over a long period of time. And actually, we're coming out of that now. We thought we were in the active phase, but then you kind of look at this and it's been pretty neutral, a couple little negatives, and then you got down here into November 16th. You really want to see like 2 or 3 weeks at least of negative numbers or neutral numbers to suggest the active phase, and one could almost presume that looking at this run here. And here we are today, the index at 0.82. Another way to get, this is a very noisy looking at it at the daily way, but then over a 30-day average, you can see we were up at 3.87, and then we got into late October and early November. Numbers kept dropping. We were in -5 or so, which would definitely suggest the active phase of the MJO. And we almost started pulling out of it. Now we're still down there, suggesting the active phase is probably still in effect as of right now. Now, if you remember looking at the models, everything suggests that we're supposed to start pulling out of this in about a week. So we'll see how it plays out. Anyway, the 90-day average then is a good way to look at La Nina, El Nino. What the trend is, well, we're positive, so that suggests La Nina. We've lost a little bit of ground, but not much. We're down to, between the difference between 7 and 4, we're at 3.94. That's not a whole lot. This suggests a continual bias towards positive numbers, which suggests a weak La Nina. And then there's the ESPI index. Instead of measuring the difference in pressure between Darwin, Australia, and Tahiti, it's rainfall, actual rainfall anomalies in the area north of Darwin and here, which is the classical El Nino monitoring area right in this area here. If the index is positive, that suggests more rainfall over here, which would suggest El Nino. If it's negative, it would suggest less rainfall and La Nina. We are at -1.3. We were actually at -1.9, what was that, 2 or 3 weeks ago, which was the lowest the index had been in this La Nina. And now we're back out of that. We're at -1.3, suggesting maybe the peak of La Nina has already passed. I don't want to say that too loud. I don't want to jinx it. But, if this moves more towards zero, that would suggest, over the next, let's say, 3 or 4 weeks, that would suggest that maybe we are past the peak already, which would be very unusual. And going back to the 30-day Southern Oscillation Index, they graphed it here for us. You can see it was positive high here back in January 2014. Here's the active phase of the MJO pushing it negative, and then an inactive phase. And you can see the bumps in the inactive and active phase of the MJO. Anyway, the whole trend was negative. This got us our El Nino back in 2015 into early 2016. And then the exact opposite happened. A big positive spike, suggesting the inactive phase of the MJO, no counterbalancing active phase of the MJO, another major spike in the Southern Oscillation Index in the, is that probably the August, September time frame? But here we go. Here's where we are now. It's just been this long-running active phase of the MJO. I thought we were coming out of it. Now we're back in it, it appears. We'll see where this goes. The suspicion is we're going to move back up in here at some point. But for right now, this is the active phase of the MJO, this long-running push is what's been responsible for all the surf of the past 3 weeks or so running, and it's probably reached its end. The models are suggesting that. So the idea is better take what you can get while you can get it, but you never know. And then, speaking of the PDO, the October numbers have posted. This is the more liberal view from Washington EDU. Positive numbers, again, represent what we call the active or the warm phase of the Pacific Decadal Oscillation. So just to keep things in perspective, so back 2013, look, all negative numbers. 2012, pretty much all negative. You go back, you see this little pocket here in 2002, 2006, we had some positive numbers, but still you got a lot of negatives, and then negatives interspersed all the way back to, where was it, 98. We went, here was the big El Nino of 97, 98, 2.76, 2.79, and then you get into, what was this? I don't know, June, and the numbers go negative. And they stayed negative for 3 years or more, 3.5 years. We had a little positive bump, and then negative, 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 deep negatives in 2011 and 12 and 13, and then El Nino sets in again, and things go positive, well positive. So anyway, the point being here, we think that from here, 98 into about, we'll just say here, I don't know how many years that is. You can figure about 16 years. That was all the cool phase of the PDO, and that maybe here we started changing, okay? And that the previous warm phase, just for comparison, ran from here to somewhere right around here. So that was 76. So, what is that, 21 years. So that was the warm phase, then the cool phase. Maybe we're heading to the warm phase again. Let's go look at another graphic. So here's NOAA's view of the data. Now it suggests here positive, positive, positive. This is by month, July, August, September. We started going negative. And here we are, October, but just a little bit negative. You know, and even in the warm phase of the PDO, you still have La Niñas, and you get you get negative numbers, but not deep, long runs of them. And you can just sort of look here. So here we'll go. We'll look at their index. So here was 2013. We'll even go back further. I mean, look at this, -3. We're just scanning the numbers, 2012, 2013. And then all the way, it's just sort of runs negative. And then 2014, that's when El Nino started. And here you go. Starts little bits of negative, but then you start getting big positives in here. 2014 and into 2015, still positive. And even though we're in La Nina now, it's still negative, but not deeply negative. And here's the overview. So here's where we are right now, the past 2 years of positive numbers suggesting the warm phase. And here is back into the, I'm not sure exactly where it is, but probably right around here. This was the last. You can see the cyclical nature, so we're trying to say negative, and then it kind of goes positive for a while. And you still see, even though there's negative numbers in the PDO index, there's definitely kind of a, here's the deepness, here's the rise, here you fall into a hole here, here's another good peak here, another hole, you know, and it kind of does this cyclical thing. And this goes back to 1870. I wouldn't believe any of that data. It's model extrapolations, but it gives you a sense kind of what's going on. And maybe, just maybe, we are working our way into the warm phase of the PDO. It certainly smells like it and looks like it, but we need another year or so of data before one can officially declare that. So to quickly wrap up, more gales on the way, focused on the U.S. West Coast, rain and weather as well, hopefully snow for higher elevations in the mountains. That would all be a good thing. Hawaii's still kind of locked out of the picture, though there's some suggestions they can be getting some surf here in the latest run of activity. The MJO, we'll call it active, but forecast to turn to the inactive state probably for a couple of weeks. There'll probably be a bit of a slack off in the storm pattern. The jet stream will probably split. And then after that, longer-term outlook suggests, again, a return to the active phase of the MJO. somewhere in, let's say, mid-December or so, and then we'll see what happens after that. Super long term, we are certainly in La Nina, but it seems to be a westward displaced and weak La Nina. We'll see if that builds or weakens as we get into the core part of winter come January or February. And then that also gives us some hints of what's going on with the PDO. Maybe, just maybe, we're starting to get out of the cool phase of the PDO and going into the warm phase. That would usher in a long-running term of more storm activity and wetter conditions for the U.S. West Coast. So that's it for this week. We'll do it again next week. Same time, same channel. Have a great Thanksgiving, and we'll talk to you soon.